Let's check. Let's balance this in basic media. So I'm going to start writing the unbalanced equation. Then decides what is becoming of Br minus. It's becoming BrO3. So Br minus on the left is becoming BrO3 minus 1 on the right. And then I look at MnO4. What is the fate of Mn? Oh, right here. It's becoming MnO2. So these are the two half reactions. So next step, balance half reactions for all atoms except oxygen and hydrogen. So in this case, we have one bromine on the left, one bromine on the right. I'm not going to touch number of oxygens yet. And on this one, I have one Mn on the left, one Mn on the right. So all atoms are balanced already except for oxygen. Next step. To balance the oxygens, add water. Can I say, if I have 3 oxygens here, I need to add 3 water. Now I have 3 oxygens on both sides. So I have been able to balance oxygens. Except by adding 3 moles of water, I really added 6 hydrogen atom. Now, in order to balance for hydrogen atom, I'm going to add 6 hydrogen ion. And I'm assuming the reaction is happening inside acidic media. We always assume reaction is happening inside acidic media. At the end, we get rid of H plus by adding OH minus to both sides of the equation. I'm going to show you that. And in this case, I have 4 oxygens on the left, 2 oxygens on the right. I add 2 water. Every water is bringing 1 oxygen, 2 water molecule, 2 oxygens. So I have got 2 plus 2, 4 oxygens on the right, and I have 4 oxygens. So now I have balance of oxygens, except I disturb balance of hydrogens by adding 2 moles of water. I am adding 4 hydrogens here. In order to balance number of hydrogens, add 4H plus. Now I have equal number of hydrogens, equal number of oxygens, and equal number of manganese. So can you guess what is the next step? Yes, the next step would be charge balance. So look at this half reaction. Do you see total charge is -1? And look at this other half reaction. Total charge is +5, right? This is +6. And here is -1. Add them together, you're going to get +5. So what should I do to +5? What should I add to +5 to get -1? I add 6 electrons. That means +5 plus -6, do I get -1? So by adding 6 electrons to the right of this half reaction, now I have got a mass balance and a charge balance equation. Now look, I mean, that's the half reaction, which is balanced. The other half reaction needs to be balanced as well. So the problem is I have 4 oxygens on the left, 2 oxygens only on the right. I need 2 more oxygens. For every oxygen, I add 1 water. So that is producing 2 oxygens as well. And if I add the 2 oxygens and 2 oxygens together, I get 4 oxygen, which is now balanced as far as the oxygen is concerned. Again, because we balance oxygens by adding water, do you see I created a problem? I have 4 hydrogens here, which I don't have hydrogens on the left. So I need to add 4H plus for 4 hydrogens. So that gives me balance of atoms. Now let's see what I need to balance charges. The charges before I add electron is 4 plus 4 charges and minus 1. They add up to be plus 3. On the right hand side, I have 0 charge. So what should I do? To plus 3 to be 0, I add 3 electrons, which gives you a charge of -3. So now both sides have 0 charge. So this half reaction is also mass balance and charge balance. All right? Okay. Can you remember the next step in balancing this redox reaction? What would be the next step? Yes, you are right. We have to make sure electrons cancel each other. What should I do to make sure? What should I multiply 3 electrons with to be equal to 6 electrons? Can I multiply both sides of this equation by 2 and the equation is still valid and number of electrons become equal to 6 so they can cancel each other? And if I multiply the bottom half reaction by 2, do I get 6 electrons here? 6 electrons. All other atoms are doubled as well. And now I have to add them together and I have to make sure electrons cancel each other because there is no leftover electrons in chemical reactions. Can I cancel these two from each other? So what am I left on the left-hand side? Can I say there are 8 hydrogens here. On the opposite side, I have 6 hydrogens. So 8 minus 6. What is 8 minus 6? 2 hydrogen. There are extra 2 hydrogen left on the left-hand side. So I got 2 hydrogens left. When this and this are canceled. 2MnO4, I write 2MnO4. 1Br minus, 1Br minus. Do you see I have 3 water molecules on the left and 4 molecules on the right? Can I say out of these 4 molecules, 3 of them are canceled, 1 is left. So this is a balanced redox reaction, which is mass balance and charge balance. Do you see on the right-hand side, I have -1 charge. Do you see on the left-hand side, -1 and -1 times 2. Minus 2 here, -1 minus 3 plus 2H. They add up to be -1. Charges are balanced, all atoms are balanced. So that's how you balance. Remember, we are still balancing this in acidic media. If we were asked to balance this in basic media, what would we do? We'll try to add OH minus so we can get rid of H plus. I'm going to give an example of that. So this is the equation that you saw in acidic media. If we want to balance reaction in basic media, we assume it's in acidic media. We use H plus to balance the hydrogen. Then we want to get rid of hydrogen ion. So we add OH minus. I have 2 hydrogen ion here. Can I add 2 OH minus? And this would result to 2 molecules of water. If I'm adding 2 OH minus on the left-hand side, can I say I must also add 2 OH minus to the right-hand side to make sure the equation is still valid? So let's check. Can I say 1 water on the right, 2 water on the left? So can I say 2 minus 1? There is 1 water left, yes? So that's 1 water. This is gone. This is gone. I had 2 water, of which one of them is canceled, so 1 water left. 2MnO4, I write it down here. 1Br minus, I write it down here. That's all I have on the left-hand side of the overall equation. On the right-hand side, I have 2MnO2, 1Br O3 minus, and also 2OH. So this is a charge balance and mass balance equation. So this is the equation that you can use in a titration involving redox reactions. So I'm going to ask you to practice what you just learned. Balance this in acidic media. How would you balance this in acidic media? Please stop the video, balance it, and come back and look at the answer. All right, I'm going to stop at this point and do the redox reactions on the next video. Thank you, guys.